Hello and welcome to the channel. So we've got a Fender M80 chorus 2x12 combo. Beast of a thing this is. I've got the camera halfway across the room to get it in shot. So this amp, when it's been running for a while, it develops a few problems. So we're going to open it up and have a look for dry joints, or double divergence as I like to call it. And we'll have a look and see what the problems are. So let's just have a bit of a look at this. We've got a couple of inputs. We've got volume, treble, mid, bass. We've got a reverb, which is very stiff. Wow, let's have a look at that. Gain, contour, presence. That's the drive channel. Volume. And then we've got chorus there, rate and depth. Got some sockets here, got foot switch socket, mono send, mono return, stereo send, stereo return, headphone socket. And we've got a couple of LEDs on here by the look of it. We've got any of these? No. To switch the channel. Oh, there's this button to switch the channels. Stood sideways from the camera, I couldn't see that for the pots. And then we've got the select for the chorus there. Right, let's take it out its cabinet, and then we'll spin the cabinet round and have a look at the speakers, because it weighs an absolute ton. So and I've got to take the chassis out anyway, so might as well do that first. On second thoughts, we'll have a look at the back first. So this amp is stereo, and there's no reverb tank in this amp. That's been removed. So obviously the tank was broken. We've got a couple of, looks like Eminence speakers here. Yeah, Eminence drivers. Small magnets on the back. Well, smallish, but yeah. So let's have a look. So there, not much to see there, is there? Plectrum stuck on there, so that shows resourcefulness. If you lose your plectrum, you've got one stuck on the back of the amp. Clever idea. Right, we'll make a start with the Temu drill, which has made a return after finding the power supply. After finally going flat after its charge, it lasted 2 months. And we're hoping to get another 2 months out of this charge, this last charge that we've just done, which was about a week ago. Right, we're just looking inside here. I've just been and checked all the Zener diodes before I started filming, and they're all in order. Look at the burnage here from these resistors. So this amp is used by a guitar teacher, and he obviously has this on for long periods of time, as I do when I'm teaching. Just put that there to get rid of that glare off there. It's not pretty, is it? So you can see here, all around here, into these components here, all the heat's just because obviously this amp been on for such long periods of time. Which is why I shouldn't sit these resistors on the board. Well, we all know that, but they still keep doing it. Here, all this area here, and these three here, you can see as well. You perhaps can't because of the lights from being so bright, but those three as well. This, you know, these have been generating a bit of heat. These two here have. They are 1.5K. But I have found something, and one of the things I've found is this capacitor here, loose, which I stumbled across when I was just checking these resistors. 2 of them there. Look at that one wobbling. Let's get something to show you what we're doing there. So if we look, you can see both of those are dry jointed, and the fact that they're that dry jointed, it does make you wonder what's been going off under this board, because they are really bad. Yes, is that again heat being generated. You can see that the heat, you know, the board is stained with the burnage there. So I think we need to look at this area. And the thing is to remember, this amp is stereo, so you know, if it's got problems, and it's got problems on both channels, then you know we need to be looking where at a stage in this amp where both channels kind of mix into the, you know, the power amp stage. But they're definitely there's major problems there. They're definitely dry jointed, and we'll probably change those caps because they're watch me say that, we've not got them in stock, but we really need to change those. They've obviously had some heat to be that loose. I mean, both of the pins must be loose on those to be like that. You don't see that very often unless there's been, you know, heat, and you can clearly see there has been here. So these, we need to look at these two resistors. See, the problem always comes with these, they sit this, in fact that was just cracked when I just, so I'm wondering if that's getting a bit brittle. We'll have to examine that. But the problem with these is that they sit them on the board, and then of course the leads are cut off underneath when they're soldered, and the resistor's just no good. It's not like you could just pull it back and, you know, a touch, pull it up a touch and resolder it. So it's always a new resistor, and you can always bet that you've not got that resistor in stock, and then you end up ordering parts. It's most annoying. And believe me, I've got parts drawers, I've got racks of parts, but still, I still constantly have to keep ordering things. There's just no need for this. Just lift them off the board. It's not rocket science. These two diodes as well, these must be emitting some heat, because that's all the way down there. That hasn't just come from that resistor. That's got to be from these as well. Yeah, there's a few bits and bobs in here. It's not massive, not major, but the getting the board out might be. There's 50 million knobs on this amp and 12 million sockets. But that's the joy of the solid state amp. And we've got a couple of bolts in the back here for the heatsink. I'd rather, can we just tip this board back? Let's just have a look. Probably can just tip it back. Right, so we've got it out the we've got the PC board out of the chassis, and a few things have come to light pretty much straight away. So if we remember when I said this pot was really tight and almost seized? Well, if we look at these pots, we can see why. This amp's had a wallop at some time, and you can see that's as bent as a 9-shilling note, and that one's bent as well. That one's had a wallop, so something's belted this amp there pretty hard, which has caused that damage. Whoa, that really is stiff with no knob on it. So that's the first thing I've found. And the second thing, wait for it, is that. So you can see on there all of this burnage big time, and I kind of half expected that from looking at the other side when we opened it up. So all across here, down here, here, and if we turn that over, you can see that corresponds perfectly with what we saw there. And someone's worked on this amplifier before. We just spin round, coming a bit, spin round. Someone's worked on this amplifier before, because there's flux all around the terminals there on the tracers where the transistors went in. So someone has been in here before. So this amp's had problems before. So either all this burnage was caused when this fault developed on here. So we're going to have to see what we can do with that. But again, if those components had been raised off the board, this got hot or not, that wouldn't have happened. You know, the worst you'd have saw probably was a little bit around the tracers, but that is just because of those components. And you just never seem to learn, Fender, or you never seem to care, whichever. And that's just at a glance, you know, looking around this amp, we could find stacks and stacks of dry joints and all sorts. There's been so much heat under here. Let me put some bigger Eltons on and then we'll have a look. So we're looking there now, and you can see they've definitely been changed, no question about it. So we'll clean those up. Need to have a look at that joint there as well. And I think that one's cracked as well there. It looks like it's got a crack in it, that one. It's a bit hard to see. You can't see it because it's actually on the other side of it there, so I don't know whether you can see that or not, but it looks like there's got a crack. We'll address those, reflow them and clean it up. And you can see it's had some more components in. So if we look here, it's had more components in there. And here, let's just go across, sorry. There, you can see something's been put in there. So what's that? Well, that looks like the reverb leads. So when they actually took this out, they've just unsoldered the reverb leads. That's what that is. But yes, if we look at these pots now, so if we just come in and look at these now, well, we've got it blown up. Now you can see, look at that one, and there, look. And if we go to try and turn that one, that's the one that's almost seized. And it's easy done with these amps. You know, they're heavy. They're very heavy. You know, you carry them into somewhere, very easy. You know, just catch them on a door frame or something, that because they weigh so much. It happens a lot. You see it quite a bit. The one on the ends also had a bit of a wallop. These Fender pots, you always seem to see it. So if we just look up, you can see this one on the end here has had a bit of a wallop as well. You see that's not quite straight, and it seems to be a running thread on these Fender pots. You see it on a lot of these Fender Twins, these that they made in the 90s. You know, the red knob Twins. I've seen that on the last 2 or 3 I've worked on. I've seen that. So yes, I think that's just a symptom of those pots. They don't need much of a tap before they've bent. So we look here, those loose capacitors we saw earlier, you could see both leads on that one are loose, and you can see that both leads of that one loose. I wonder if one of the leads has snapped off that one then. Another one dry jointed there. So yeah, quite a few things to sort out of this amp. Right, I had a word with the customer, and he just uses this amp for teaching. It's all this amp's ever going to do is sit in a teaching room being played at a very low level. So it doesn't use the reverb anyway, and the tank hank's not there, is it? So we don't need to worry about changing these pots. It's run for years. Obviously he's not bent the pots. It's run for years like that, so that's not going to be an issue. It doesn't use the reverb anyway, so we don't have to worry about that. And it's the reverb pot that's seized, obviously. So I'm going to go around, sort all the dry joints out. This has occurred when this amp developed a fault at some time, and obviously these transistors have been changed, so all of this heat here has been this has been caused by excessive current. Now I'm just going to fix this amp up, make sure it's safe, make sure we've got all the dry joints sorted out. We'll have a bit of a go at cleaning this. We'll clean all this flux off of here, just make sure that, you know, there isn't a fault and they're not getting excessively hot. So the symptoms on this amp was it runs fine for a while, and then the longer it's on, it just seems, the sound just seems to get thinner and more weedy, and it gets quieter. So that, again, that's probably, again, just dry joints and things. And obviously we know we've got those problems there with those caps. So right, we've had one or two comments for more gumption on the channel, so here it is, the gumption. And for those that have only subscribed to the channel recently, this was sent through the post to me anonymously. So I have a tendency to say, oh, we'll put some gumption on that, we'll clean that with a bit of gumption, and then this suddenly appeared. As you can see, it's really old because it cost 1 shilling, and if we open it up, you can see there inside, and it's got quite an aroma to it. It's hard to describe the aroma, really. I should maybe have some scratch and sniff cards made, vintage guitar amp repair scratch and sniff cards, or maybe turn it into those air freshener things that you hang in your car. So yes, if we take this out, you can see on there. So yes, so and it's obviously that you get a bit of a wet cloth there and get some of this gumption going. Must make a concerted effort to use more gumption. So I've tried to clean this board with the alcohol, and absolutely nothing's coming off there at all. There's nothing's really come off it. It's just, when you hold it into the light, you can see it's just a bit scorched. It's not, and it's not got to the point where it's coming apart or anything. I'll check around the traces. Oops. You see there, that's relatively clean, so let's just put us on manual focus again. There, you can see that's relatively clean, so there's nothing doing there. So I think I'll probably just reflow those again, clean the flux off. These sockets have been resoldered here. There's flux all on those. You can tell those have been done, and they've been done very well. Just not clean the flux off, but nothing wrong with the soldering. So we'll just finish off with a bit of this. This doesn't leave a residue at all, and this is contact cleaner, but it's food processing safe. It leaves no residues. It's not alcohol. Forget exactly what it is now. Yes, it's also quite flammable as well, as I found out last week, because I decided I was going to burn a lot of old invoices, paper invoices and things like that from previous accounts that are over 7 years old. And I've got one of those little metal dustbins, you know, with the holes in and a bit of a small chimney on the top there. So I filled it up with bills, and I just got the lighter, lit one, put the lid on, and I thought I'll just spray a bit of this in just to get it going, and sprayed it down the chimney, and yeah, it almost removed my eyebrows. So yeah, it's quite potent, this stuff. It's and it's quite expensive to buy as well, but it is very good, and it doesn't leave any residue at all. It does dry pretty quick though. It does evaporate pretty quick. It's actually pretty good for cleaning pots, because you spray it in and it dries so quickly. And it cleans so well cleans really well, but because it evaporates so quickly, it doesn't dissolve the grease in them, you know, because if some contact cleaners just thin all the grease out, but this is yeah, it's really good stuff. Right, so I've just tested one of these capacitors in this area where there's been some heat, and you can see that's got an ESR of 5.3 ohms, so it should be 4.7. So that's they're not in great shape. So I think what we'll do is, because it won't take long, and I've got them in stock. We've got 22s, some 4.7s, and a 47. Let's just got to be careful with this board because of the sockets there. But yeah, you can see them, these here. So I think what we'll do is we'll just, there's 6 of them. I think we'll change those. Won't take long to do it. The thing is, I've got to solder around them anyway. It doesn't look like there's much solder on the tracers, and they could be a bit dry jointed. So I think I'll just swap those because they've had a bit of baking. I've got 2 here. I'm not going to go too mad with this amp, but we'll just, you know, anything that could. Remember, one of the symptoms of this amp is when it's been on for a while, it starts to get a bit weedy and thin. So we'll just go around and just check a few capacitors and things. So we've got one here. This is 10 microfarad. And actually, the fact that they've left a little bit of extra lead on these is good, because it means I can get the cap tester on. So he's 109 at 0.16 ohms. So a little bit over, as it should be 100. Here's the other one, I think. And he's the same. So exactly the same, in fact. So they'll be okay. Remember, we're not, you know, we're not setting out to restore this amp or whatever. This amp is purely a work tool. Right, just took the first one out, which is 2.2 microfarads, and you can see 0.88 microfarad at 40 ohms. So you can see what the heat does to them. And there's the second 2.2 I've took out of the board, and you can see that's toast as well. There's the third 2.2, 1.88 at 7.5 ohms. So he's shot. Right, I've got this back together. So we've had to do quite a lot of work on that PC board. So I've lifted these resistors up. Well, I put new resistors in actually. I'd got some of these in stock. I didn't think I had. So we've got a 7 watt 270 there instead of a 5 watt, made that fit. And we've got the 270 there, which is 7 watts. So we've got 2 7 watt resistors in there. We lifted them off the board. I had to do some repairs on the bottom of that board because the tracers were damaged where these resistors went through with the heat. So we've had to just scrape off the tracers to get to the copper, and then I've actually just laid the leads across and soldered them in to make them more secure. I've got the board back in now, and I've changed quite a lot of capacitors in here. So these have all been changed here. So 3, 4, 5, 6, 7. We did have a look at one of those, and you could see they were all shot with just the heat from this board. And I've tested the others, they're good. There was one that was actually falling out and actually fell out in the end. So I've replaced that one. Checked all of these all the way through. Had these capacitors out. Just move this across a bit. So had the main electrolytics out and tested those. They tested okay, because I've got to make sure that there's no shorts on this amp. Tested the output transistors. I've run this amp up, and it runs. Tested the voltages across these resistors. So we've got 40 volts going to each of these resistors, and they're dropping down to 16 volts. So we've about 24 volts going across these resistors when we're off the bulbs. And I did the maths on that, which get the calculator. So we've got about 24 volts, slightly less, but we'll say 24. And if we divide that by 270, we've got 2 watts, 2.1 watts there. But they get red hot, absolutely red hot. There's no shorts on this amp. It runs absolutely fine now. Checked the current, the bulbs are dim. Even with a 100-watt bulb in, it's relatively dim. Once you go over that, the bulbs, you can't even see them lit. So we're not drawing any excessive current. Checked everything. A lot of dry joints in there, a hell of a lot, and some of those weren't anything to do with it. You know, they weren't in this area. We had quite a few in the preamp, well, this area where the send and returns are and things. So a lot of dry joints to sort out. Very stingy on the solder, Fender, with this amp. What else? Yeah, the chorus, I don't know whether this is something to do with the amp or what. The chorus only works on one channel, and I've not really read up how this amp actually works. Looked at the schematic, and half of it's missing. The schematic online, that you can't find the power supply section of it, so that's missing. The chorus works on one channel but not on the other. The channel switch is okay, everything works there. So basically what we've done with this amp, we've got it up and running. This amp is just going to sit in a room and be played at a very low level. It's just going to be used every day. Basically, I've just extended the life of it. You know, this amp's probably got another 2, 3, 4 years left. That board's not in great condition, but still usable. I've even raised the diodes. Luckily, these 2 diodes, they'd left some lead on them, so I've managed just to raise those up slightly. Right, I'm just doing the final checks on this amp, and I'm checking the fuses. So I've got 2 fuses here. So I thought I'd check on the schematic just to see what value they were. There's nothing on the schematic at all. Nothing about what fuses should be in this amp. We've got a 2 amp fuse in the mains, which is probably about right, I would think. So we've got 2 fuses here that look like they're connected to the secondaries. And they're 10 amps that's in this amp. 10 amp fuse. You can see that. Right, I've done a bit more checking and I found a parts list. And it's saying these fuses are 8 amps. But I'm not 100% sure if that's the case, whether it's this model or whatever. So what I've done is I've just put the meter across one of the fuses there. And you can see there I've got 0.4 of an amp on there. Now if I flick that off and we watch carefully, we'll just let the power drain. You can see we get 1.1 amps there just for a second flash up. So if I go to the volume on here now, and I have got the bulbs on at that, so I'm going to take the bulbs off now and just see what we've got. So with the bulbs on now, off now, we've got 3/4 of an amp, 0.8 of an amp. So almost 1 amp. So let's switch off now, let it drain. And you can see there we had 1.13 amps there when we fired up. These are quick blow fuses, by the way. So now we've got 0.8 of an amp. Remember, we had a 10 amp fuse in there. So it's on a dummy load, and I'm going to crank this amp. And it's on the overdrive channel. So crank the amp up there. We're up to 1 amp. And now we're just going over 1 amp. So I'm actually winding all the controls up. 1.16 amp. That's a lot of fuse. That's a lot of fusing for 1 amp, 10 amps. there's nothing on the schematic says what fuses it should be. There's one sheet of the schematic missing because it says sheets 1 of 2 for the schematic, and then when you go to the layout it says sheet 1 of 1. So there's obviously a sheet missing, and that's probably got all the fusing information on. I'm not comfortable with 10 amp fuses in this. At the very least, we've discovered that you know, only 8 amps required for this, and I'm not even sure whether that's correct, to be honest. So I've put a couple of 6.3 amp fuses in this, and the reason why is that, again, this amp's not going to be cranked up, so this amp's now idling at a very low level now, and it's idling at around 3/4 of an amp. So even with a 6.3 amp fuse, if we account for, we're switching it off now, if we account for the power surge when it's turned on, we'll let the voltage just die out. You see, that time we didn't even get, but the biggest I've seen is about 1.3 amps. So even accounting for that, if we say three times that, that's still only about 4 amps. So I think 6.3 is more than enough, and it does make you wonder, doesn't it? Now, having seen that, they're actually on the AC feeds coming in from the transformer, those fuses, they're on the secondaries. But it does make you wonder with this amp, it's developed a fault at some time, because we know it's had the transistors changed. It's developed a fault at some time, or it's had a transistor that's leaking, shorted, whatever. It's whooped the current up on this amp, and obviously the fuses haven't blown, and it's burnt all the board, and you know, it's at some point this amp's got excessively hot. We know that. Is that because of those fuses? I don't know, but it seems rather high to me. 10 amp. I mean, you know, you're pushing into car fuse territory. You know, if this was a PA power amp, you know, something that were like 400 or 500 watts a side, I could understand it. But this thing is just, it's not drawing that much current. So I think 6.3 is going to be plenty in this amp. I think those fuses are just way too big. I could be wrong, but if I am, I suppose they'll blow eventually, you know, if they're too. But as I say, that's what the meter's telling me. If we've been off for a while now, so if we flick on 1.38, so 1.4 amps. So for if you go 3 times what, you know, on the fuse, you're looking at 4.2 amps. So I think that's rather large. 10 amps. I think 8 amps. Even 6.3, really, there, it to me just seems still too big for this amp. But there we go. Generally, you know, most people, what do they rate a fuse at times 3 of what the maximum current is? So we know what the maximum current is because we've just seen it flash up. 1.4 times 3. There is about 4, just over 4 amps. And we've got 6.3 in there. So I'm sure that'll be plenty. Ideally, I think 5 amps would be about right for that. But let me know what you think in the comments. But anyway, I'm putting 6.3s in it. We'll button it back up and I'll start waffling. We'll button it back up and then we'll have a bit of a listen, I think. Right, let's give it a blast. So we'll start with a clean channel. This amp is seriously loud. I can't even get this amp on number 1 in here. Something like that anyway. So that's the clean channel. It's a very bright amp as well, so this, you have to be careful with this guitar, keep the tone down on it. And you can see this, I've got the gain up there to about number 6. Now this channel just has a presence and a contour, and I've got the presence all the way down on this. Let's go for full tilt. Moving the contour. Oh, this thing is so loud. Got the chorus in. Keep falling off. Something like that. Very rusty at that at the minute. Yeah, so there we go. Just flick that off because it's a bit noisy. So I've got the chorus blasting out there. Yeah, it's so there we are, the Fender M80 chorus, which had severe dry joint problems, and yeah, we saw the state of the board. A lot of capacitors damaged there through that heat. It's running a lot better now, and yeah, should get a few more years out of it. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.